So we're going to start with number 33, okay? And if you don't get all this, you can obviously look back at it. 2 times the difference of n and 3 plus n times the sum of 2 and negative n is 2 minus n squared. Don't worry, we're going to learn about squares soon enough, but right now we're just going to dabble in them a little bit. First step is going to be to distribute. Here and here, here and here, there's nothing to distribute over there. 2n minus 6 plus 2n minus n squared. That's the component that tends to make people nervous. The n times n is n squared. It's a negative anyway. All of that is equal to the business on the right that's still sitting there, right? Can we collect anything on the left? I think we can. We can collect our n's anyway. But the n squared cannot get combined with the n's. N squared is something completely different from n. Okay, n is n to the first. So you cannot collect anything beyond these two pieces. Once you've collected like terms, your goal needs to be to get a single variable on one side and a numeric answer on the other. So let's start working that system. Yeah, add your n squared, and but what that's going to do is cancel it out. It's going to really clean up the equation for you and eliminate any concern you might have had. Can you solve it from here? Easy peasy. Okay, so when you're dealing with squares at this level, you're going to be canceling them out by adding them or subtracting them, depending upon what their sign is, okay? Don't think your answer is going to be n squared is something. If you have that type of an answer, there's an error somewhere. Okay, you have not learned that yet. But you will. Okay, 2 more. Here's number 35. Told you I'd be quick today. Here's number 35. 3 halves multiplied by 4x minus 6 minus x times 3 minus x is equal to, good grief, 1/3 x multiplied by 3x plus 6. Hopefully I copied it right. Let me check that. 3 halves, 4x minus 6, minus x, 3 minus x, equals 1/3 x, 3x plus 6. Okay, a lot of work to be done here, and this is an easy equation to do, and also it's easy to screw it up. So let's see if I can do this right. The result there, after you do 3 halves times 4, is going to be what, 6x? The 2's reduce here, giving you 3 times 2. And 3 halves of negative 6. So we should have a 9, am I right? Ethan, am I good? 3 halves here, 3 halves there, very good. Here's our next 2 pieces. A negative x times 3 is a negative 3x. A negative x times a negative x is a positive x squared. 1/3 of 3x, 1/3 x of 3x is 1x squared. The 1/3 and the 3 reduce to a 1, but x times x is x squared. And 1/3 x of 6 is 2x. So just to kind of look at this piece for a minute, 1/3 times 3 times x is literally what happened here. Okay, so these canceled each other out, leaving us only with x times x. That's how this came about. The second piece was 1/3, and I'm just gonna commute this over. 6x, that was the second piece. The 3's and the 6 reduced, giving us a 2. 2 times x. That's how we ended up in that position there. Okay, so just to highlight, that was this first piece, and this was the second piece. All right, collect like terms, shall we? So what do we get? 3x plus x squared minus 9 on the left, x squared plus 2x on the right. Your x squareds are going to cancel each other out. And you're going to end up with 3x minus 9 being equal to 2x. How do you guys want to play this? You want to move the 9 and then subtract the 2x? Yeah, I know. Leaves you with a 9 on the right and an x on the left. And that is exactly right. So the reason I wanted to show this clearly was because of all the mistakes that could be made with the multiplication there. Hopefully this will help you a little bit. Here is the last one that I feel has worth for you. And it's because it's brackets and braces. I sound like an orthodontist. I know, it wasn't very funny. 4 minus r multiplied by 3 minus r closed is equal to 2r minus 3. R squared minus bracket 4 minus r parenthesis 3 minus r parenthesis bracket equals. Okay. When there are multiple layers of symbols of inclusion, do the innermost symbol first. And on the left-hand side, the innermost happens to be this. So we're going to distribute in our negative r into both of those pieces, which results in a negative 3r and a positive r squared. Remember, negative times negative is positive. Now all we have left in this mess is this. But here is the huge problem I'm about to show to you. I'm just working the left right now. This negative has to be distributed into each piece that lives inside. You are not just subtracting the 4. You are subtracting all of this, which means it looks like this. A negative positive 4 is a negative 4. A negative negative 3r is a positive 3r. A negative positive r squared is a negative r squared. All of that is equal to, we could easily work this without having any fear, 4r minus 6, right? Let's collect like terms. Looks like the r squared and the negative r squared, once collected, cancel each other out. Gives me negative 4 added to 3r being equal to that on the right. I'm pretty sure you guys can solve it from there, but we'll go ahead and whack this real fast. We're going to maneuver our r's, and as long as we're at it, on the same line, if you choose to do it that way, that's fine. The answer is 2. Now, one thing everybody hates, but I'm just going to recommend it. I know that it takes an awful lot of paper to show this level of detail, but what I am finding in your homework and every other year of this, the more detail I'm able to see, the more I can help you, and the more you guys are finding your own mistakes. I mean, and it's okay by me. I would rather find this, see something scratched out and erased and fixed, then see it all jumbled together, and I can have no hope of being able to describe for you where the error occurred. Okay?